Bio-oil. Bio-oil is not chemically exactly the same, but in some processes can be used as is. Bio-oil is made from pyrolysis, which is a process where you cook stuff and it releases gases and liquids, or the gases cool down to liquids once they cool off. Bio-oil is just black like crude, and it's has water weight into it, and the quality depends on the feedstock. Advantage about bio-oil is the problem dealing with the food. Before such processes, to get liquid fuel you had to make ethanol, which was quite wasteful, because you have to ferment fuel, and you have good feedstock. It's food. Food feedstock is not exactly the easiest to harvest. Bio-oil, no more of a problem in terms of, like, say, with that feedstock is now junk. Like, say, paper waste, wood waste, food and trash are ideal feedstocks. Crops that you grow for bio-oil is wild weeds. Basically, you let a field go wild, and in the summer you harvest it, or you grow hay. And another is algae. The most interesting thing that bio-oil can be used for a base for many and refineries for many petroleum products. It can be used to make synthetic gasoline, biodiesel, and bio-oil in its raw form can be used as fuel oil. This might be critical in the future when petroleum products or petroleum is becoming scarce and companies need basically a petroleum substitute, and that's what bio-oil is used for. And maybe in the future another process treating the feedstock can get the bio-oil much closer, because obviously it's not millions and millions of years. It just takes several hundred to build up that waste, and when it's composted just right, it all needs to be cooked. It takes a few seconds for it to cook if it gets in the right place, and you got oil and cool. And it's amazing that we can just, I call it green bio-oil is another word, because the feedstock is non-composted. It'd be interesting if you actually use trash and slightly composted stuff that has been more, let's say, hydrocarbonized by the from the process where it has no oxygen. I hate the back of this looks like, oh well, I think that's just about it. Okay, but economics. It all depends on your feedstock. From trash, bio-oil can be very cheap to make, or like say a different process for a second generation fuel. It's still very cheap. If the feedstock is about $18, you make bio-oil for roughly like $30. Then you refine that stuff and you add another $10, and bio-oil's energy concentration is about equivalent to ethanol. So, but mind you that it's much more efficient, much more cost effective, since less fuel is wasted in fermentation. And also you can make any synthetic fuel you want through refining, or you can just skip the pyrolysis process and go from, like, say, catalysis and make synthetic diesel fuel and gasoline. If you're using the feedstock, if you had like a ton of hay that cost you around $100, you would make 1 gallon of bio-oil would be 87 cents, because roughly hay is, I think, structurally similar, so it's going to get at least that. Then for refining it to synthetic gasoline, you probably would need 2 gallons plus $10, so you roughly $2 a gallon. And if you give that fuel to farmers, then you can cut the price, reduce the price again, because a lot of hay is due to high fuel prices, so the cost of 1 ton of hay is pretty high. So to make cheap fuel, first we use waste, roughly make it very cheap. $1 per gallon is the average from most sources of research. Basically, that's the economics. Very, very feasible. If you're using waste materials, in the future we'll use algae or hay, anything that grows fast and has a lot of cellulose in it. Like, say, that's why hay is I consider it a good feedstock once we exhausted all our trash and waste. Of course, waste is where we're going to begin. I think that's just my addition for the economics section of this video, saying that it is cheap, 4 times as cheap